Linear correlation. When two variables are mathematically associated, they are said to be correlated. The correlation coefficient measures the degree of relationship between these two variables. And in order to get this, we will use the formula of Pearson product moment correlation coefficient, which is known as R is equals to N. N is the number of sample space or the sample data, times summation of X and Y. X and Y is the two variables, minus summation of X times summation of Y, all over the square root of N times summation of X squared minus quantity summation of X squared times N summation of Y squared minus quantity summation of Y squared. So, for example, we are given this data. 10 students which have their records of proficiency score and their course grade. And we are asked to compute and interpret the correlation coefficient for the data of proficiency scores versus their course grade. So, looking in this data, we know that we have 10 sample space or 10 sample data, so N is equals to 10. And we're not yet finished. We need to find the product of X and Y, so we can just substitute it here. We need to find the summation of XY, the product of these two variables, and we need to get the summation of X, summation of Y, and we need to find the square root of X and the square root of Y and the summation of it. So first, we need to find X and Y and the summation of it. So in order to do that, we just multiply X and Y for every student. So for example, for student number 1, we have the value of X which is equals to 60 and the value of Y which is equals to 70, and we just multiply X and Y, so we get 60 times 70 is equals to 4,200. And we do the same method for every student, for student number 2, student number 3, and so on and so forth. So we've come up to this data. This is for student number 1, student 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to find its summation, so just add it. Add the summation of XY of student number 1 to student number 10. Adding this all, we'd get 55,875. So finish to summation of XY. We need to find summation of X squared, summation of Y squared. So summation of X squared for student number 1, you just get the square root of 60. 60 times 60 is equals to 36. So doing the same thing to student 2 to 10, we get the value of X squared. So summing it all, we get 54,200. So we have the value for summation of X squared. And lastly, we need to find the summation of Y squared. So the same procedure we have done to summation of X squared. We've come up to this data. Then summing Then adding it all, we get the summation of y squared, which is equals to 58,025. Okay. From what we've done, we get these values. So we get the summation of x, which is equal to 730. Then we have computed for summation of x squared, and then we get 54,200. We also get summation of y, 755. For summation of y squared, we get 58,200. 58,025. Summation of xy, we get 875. And then getting these values, we have to get the correlation coefficient of these two variables. We just substitute these values to the Pearson product moment. We substitute these values to the Pearson product moment correlation coefficient formula. So substituting this formula, we get n, which is equals to 10 times summation of xy, which is 55,875, minus summation of x, which is 730, summation of y, and then all over this. So substituting our given values, we get their relationship, or their correlation coefficient, 0.79. This indicates 0.79 indicates a good linear relationship between the proficiency scores and the final course grade.